Hello and welcome you all on my YouTube channel JK Academy India. In this video, we will discuss about the actual transformer phasor diagram and equivalent circuit and short circuited secondary of transformer and its equivalent circuit and phasor diagram. So let's start. Here in this figure, as shown, R1 is the resistance of primary winding, R2 is the resistance of secondary winding, X1 is the reactance of primary winding, X2 is the reactance of secondary winding, R0 is the exciting resistance and X0 is the exciting reactance. So the primary impedance will be Z1 R1 plus JX1. Supply voltage is V1, not V2. V1. The resistance and leakage reactance of primary winding are responsible for some voltage drop in primary winding. So V1 equals to E1 plus I1 into Z1, where I1 is I1 dash plus I0. I0 is the no load current and I1 dash is the uh, primary current. So the secondary impedance in the circuit will become R2 plus JX2. Similarly, the resistance and leakage reactance of secondary winding are responsible for some voltage drop in secondary. So V2 will be E2 minus I2 plus R2 JX2. Why minus sign is here? Because the final voltage we are getting in the secondary is nothing but the difference between the EMF induced in the secondary minus the losses. Now the phasor or vector diagram of this actual transformer for resistive, inductive and capacitive loads are shown here in this figure. So for unity power factor, the phasor diagram will look like this. This is the magnetizing current and this is the total primary current. This is the resistance drop and this is the reactance drop, and this is the total impedance I1 Z1. This dotted line, and V1 vector will be, so in the here V1 will be E1 plus I1 R1 plus JX1, I1 JX1, and the secondary current is just 180 degree out of phase with I1 dash, and secondary resistance drop I2Z2 and impedance drop will be I2Z2. For lagging power factor, this is V1 and this is V2, and there will be some angle difference between V2 and I2, and it is phi 2. Similarly, uh, there will be the same angle difference as in case of unity power factor phi 1. Here I1 and V1 is also having the same power factor. When the load is capacitive, the power factor in between I1 and V1 will remain same, but in case of secondary voltage and current, the power factor will be different because the load is capacitive and power factor is in leading. Now, equivalent circuit when all the quantities are referred to secondary. So here R1 dash will become K square R1 as we have seen in earlier videos, and R equivalent will become R2 plus R1 dash. Similarly, the primary reactance X1 dash will become X2 and K square X1, and equivalent reactance will become X2 plus X1 dash means K square X1. So here we are getting one relationship that I2 equals to I1 upon K. K is nothing but the transformation ratio, and E2 equals to KE1 or KV1. So the total impedance, equivalent impedance referred to secondary side will be ZES equals to RES plus JXES, and the secondary voltage will be E2 minus I2 and ZES. Phasor diagram for this type of quantities is shown here. For the unity power factor means resistive load, inductive load and leading power factor. So the phasor diagram of a loaded transformer when all quantities are referred to secondary side for resistive, inductive and capacitive load are shown. The voltage drop in resistance vectors are taken parallel to the current vector. So this is the current vector I2, and I2 RES is in the same phase. This is the I2 XCS, and this is the total impedance ZES equivalent impedance, and what the voltage drop in reactance are taken quadrature to the current vector. This is for lagging power factor. There is a angle in between I2 and E2. Here that angle is in leading side means I2 is leading phi 2 by vector V2. Now equivalent circuit when all quantities are referred to the primary. So R2 dash will become R2 upon K square, and R equivalent will be R1 plus R2 dash. Secondary reactance referred to primary will be X2 dash equals to X1 upon K square, and the equivalent reactance will become X1 plus X2 dash. Total impedance referred to the primary will be REP plus JXEP, and the voltage V1 will be E1 plus I1 Z equivalent. Phasor diagram for such type of quantities is given here. For the unity power factor, this is for lagging power factor, and this is for leading power factor. As discussed earlier, phi 2 is the angle between I1 and vector V1, and here the phi 2 is an angle between E1 and I1, it is on leading side. Now we will discuss the short circuited secondary of transformer. If the secondary side of the transformer is short circuited, V2 becomes 0, which makes E1 equals to 0 because E1 is equal to E2 upon K equals to V2 upon K. The equivalent circuit of transformer when all quantities are referred to primary side with short circuited secondary is shown in figure this. In this case, V1 is the applied voltage, REP, XEP and ZEP are the quantities referred to the primary, and this is the short circuit current I1 AC, E1 equals to E2 upon K and V2 upon K equals to 0 because secondary is short circuited. On short circuited, applied voltage V1 is just utilized to circulate the current I1 SC, that is the short circuited current, in the impedance of the transformer referred to the primary ZEP. The phasor diagram for short circuited is shown in another figure. Here it is. This is the phasor diagram. This is the short circuited vector equals to I1 SC plus REP, and this is the I1 REP, that is the equivalent resistance, and this is the reactance current, and this is the first vector of short circuit current. Now at normal voltage, short circuit current I1 SC will be V1 upon ZEP drawn by the transformer is very high as compared to the full load current. This current may damage the transformer. Power and distribution transformers are designed for high leakage reactance so that the short circuit current is limited to 8 times for the large transformer and 30 times for a small transformer of full load current. This is the main important point. However, if the transformer is short circuited on the secondary side intentionally, so perform some test, uh, to perform some test, a very low voltage V1SC nearly 2 to 5% of the rated value is applied at the primary terminal. Then we get the equivalent impedance. Power under short circuit can be calculated by the equation I square R, and REP is nothing but the power divided by current, and equivalent reactance will be this. So thanks for watching. Again we will come back with a new video of the transformer. Thank you and take care.